Alrighty, welcome back, boys and girls. It's your main math man, Shank, coming to you live from Southern Academy. In this video, working on our unit number 5 still, working on lesson number 10, trying to talk about some functions. So for the first part, it says this. It says, what do you notice and what do you wonder? So what I want you to do is maybe think pair share, work with your partner, try this out. Or you could say this. You could say, I would say pick one of each of these things. So some things that I notice, you could say some things I notice about this graph are, for a sentence starter, you could say not all the points are on the line. You can say the temperature gets warmer and then cooler as time goes on. Or you could say that 5:45 is the warmest. Again, I'm able to kind of notice those from the picture given. Then some things that I wonder, or things that I have questions about. I could say some things I wonder about the graph are, what location does this data represent? Why is it warmer at 6 a.m. than it is at noon? And why aren't these points connected? So I'd say pick one of these for each list, and write them down. All right, on the next part, it says this. It says approximate the percentage recycled each year with a piecewise linear function by drawing between 3 and 5 line segments to the approximate graph. So what we're going to do is going to try to connect these. So we're going to graph these first. So I can graph a couple lines here. I can say, all right, I can go from 1991 to 1996. It's going to be one segment. Notice how they're real close to that line. I can do a different line and say, let's say from 1996 to 1999. So let's do these three. Let's try that again. But from these three goes on. And then I can do, let's do red this time. And I can say another segment is going to be from 99 to, let's have the whole way up to 2011. So notice how there's that pattern there. And then lastly, it kind of goes down at the very end from 2011 to 2013. So notice how I have, different lines for each of these. And so what I can do is I can graph or write the ordered pairs that goes along with it. So I can say this point right here is going to be 1991, and the amount would be about 16%. I can say this point here is going to be 1996 and 22%. The other changing point right here is going to be 1999 and 21.5%. Then this point up here is going to be 2011 and 26%. And this last point, or this end point that I can have, is 2013 and 25%. And I need these because if I look at number 2, it says find the slope for each piece. What are the slopes tell you? Well, it has from each of these points, if I was to find from, I could say from 1991 to 1996, I'd be able to say, well, this slope is, this is plus 6, and this is plus 5. And if I do that for each of those, I can write it as a fraction. So I can say, reading from left to right, I have these. I have 6 over 5. I have the next section is negative. Let's actually do colors for this. So let's say green part is 6 over 5. Then I have the purple part is going to be -1/6. And I can say the pink part is going to be 3/8. And the last slope that we have, that blue part, is going to be -1/2. And I get that by finding the change in y over my change in x. So just make sure you're remembering your slope is always going to be equal to your change in y divided by your change in x. And if I look at each of these, I can kind of notice and look at the values too, but I can say that, hey, this one right here is going to be the steepest slope. Steepest slope. And that makes sense because if I'm looking at each of these 4 parts, the green line is the steepest. And for the next part, it says, we're talking about a dog bath. It says Elena filled up the tub and gave her dog a bath. Then she left the water out of the tub. So number 1, it says the graph shows the amount of water in the tub in gallons as a function of time in minutes, and we want to add the labels on this graph. So we want to make sure we can label our axes. So I'm going to say that our y-axis is going to be the volume in gallons, and our x-axis is going to be the time in minutes. So we label our axes, and then it says for the next part, when did she turn off the faucet? Well, if we look at from left to right, notice how it's gaining water, gaining water, gaining water, and then it stops right here at this point. So we're going to actually say that after 6 minutes, the volume was increasing until t equals 6. So after 6 minutes, meaning on our x-axis it stopped, because it didn't change after that. So that's kind of like the tub filled up, and then this is when she washed. So for number 2, it says when did that was number 2. So then for number 3, it says how much water was in the tub when she bathed her dog. So it would be 24 gallons, because if we looked at when she started washing at t equals 6, and then started draining at t equals 18. So at this point right here is where she started to drain the water, because that's where the water amount starts to go down. So this part right here is where the bath took place, or the bathing, I should say. All right. That says for number 4, how long did it take for the tub to drain completely? Well, if we go from t equals 18 to t equals 30, it would take 12 minutes total. So just be able to find, on your graph where those 2 points are at. So we're saying from 18 the whole way down to 30, because that's when the volume becomes 0. And it says at what rate did the faucet hit the tub, or fill the tub, I should say. So we have to find some points here. So let's say if I draw out my table of values, I can say, okay, it started at 0, 0 down here, and then it went up to 6 and 24. Make sure those 4s are good. Find my change in y, that's plus 24. Find my change in x, that is plus 6. So I can write it as a fraction like I showed before. So I'm going to say I have 24 divided by 6 is going to be equal to 4 gallons per minute. So make sure you can write your slope as a ratio, meaning as a fraction. Then same idea on this left side, it says at what rate did the water drain out of the tub. So I'm going to go from this point 18,24 to the point 30,0. So let's draw this table. So I'm going to say from 18,24 to 30, 0. Well, I subtracted 24 to get to my next point, and I added 12 to get to my next point, or the x-axis. And so I can write that as a ratio. So I say negative 24 over 12 equals negative 2. But I can say, well, since it's draining, it would be 2 gallons per So the tub drained at a speed of 2 gallons per minute. All right, moving to the practice now. It says the graph shows the distance of a car from the home as a function of time. So again, notice how it's the y-axis is a function in terms of the x-axis. It says describe what a person watching the car may be seeing. So we could say something like this. We could say the car is driven away from the home, then waits, and then the car is driven back home at a slower speed than it was driven away from home. An example, this would be, so I could say example would be drive to work or school and then back home. So we're saying, notice how you go, the distance from your home increases, so that morning commute is faster. Then that distance stays the same because you're at school or work, and then you drive home and it's maybe a little bit more traffic since it's in the afternoon. And then towards the back, it has for number 2, it says the equation and the graph represent 2 functions, and it says use the equation y equals 4 and the graph to answer the questions. So what I can do is I can graph this out actually. Let me actually graph out the equation. So I'm going to say graph first. That way it's a little bit easier to see. But I can say, well, if I graph the equation y equals 4, that's just the horizontal line on that point where y equals 4. So I'm going to say this is my function y equals 4. And then I have this other line in black, but I don't know what the equation is. For part A, it says when x equals 4 is the output of the equation or the graph greater. Well, I'm going to actually say that if I look at this point here, I can say I'm comparing when x equals 4, so I find where x equals 4. Here's my graph, here's my equation, and so since y equals 4 is greater, I'm going to say the equation y equals 4 is greater because 3 is less than 4. For part B, it says what value for x produces the same output in both the graph and the equation. Well, real simple. I'm going to find where they intersect, so that's going to be this point right here. So this is going to be our point of intersection. Again, that is where my 2 lines are equal. So I'm going to say my point of intersection for this system, or these 2 equations, is going to be 6, 4. And so the x value from that is going to be just 6. For number 3, it says this graph shows a trip on a bike trail. The trail has markers every 0.5 kilometers, showing the distance from the beginning of the trail. So for the first part, it says when was the bike rider going the fastest? Well, if we look for when we say the fastest, so let me draw this out. When I say the fastest, I'm talking about the steepest slope. And actually, if I look at the steepest slope, it's going to be this section right here. Notice how it changes very rapidly. So I'm going to say that is going to be between 2.4 and 2.6 hours. So find on your graph where that's at. It's talking about from 2.4 to 2.6. Notice how that section is the steepest. And it says when was the bike rider going the slowest? Well, we can say if we exclude those points where the rider is stopped, or the times when he stopped, we can say between 1.4 and 2.2. So that's going to be this section right here. Notice how it's the least steep compared to the others, and excluding the time where the rider stopped. So the flat part is where they are stopped. And it says for part C, during what times was the rider going away from the beginning of the trail? Well, since our y-axis is the distance from the beginning, so we're going to say this. We're going to say going away from just means distance was increasing. So what we can say for that is between 0 and 2.2. So if we go the whole way from 0, notice how increasing, and from 2.2, that's when it kind of drops off. So they were about 2.2 hours out from the start is when they started to head back to the beginning. And it says for part D, what times was the rider going back towards the beginning of the trail? So we're going to say now, I'm going to flip that and say if they're going back, that just means that they are the distance is decreasing, meaning our y value is going down. So that's from this point going down. And so that's going to be from the point 2.4 to the whole way to 3 hours. And then for the last part, it says when did the rider stop? And that's going to be, underline that again, when they're stopped. That just means when the graph is flat, meaning the slope is 0. Well, if we look at some of those parts on our graph, we can say between the times of 0.8 and 1.4, which is from here to here, and from the 2.2 to 2.4, which is here to here. So those two sections is when they were stopped. Then lastly, for number 4, it says the expression negative 25t plus 1,250 represents the volume of a liquid of a container after t seconds. And that makes sense because if you're draining the liquid, it's going to have a negative slope. Then it says the expression 50t plus 250 represents the volume of liquid of another container after t seconds. So maybe it's draining into that. So it says, what does the equation negative 25t plus 1,250 equals 50t plus 250 mean in this situation? Well, we can say this. We can say the equation says that the volume in one container is equal to the volume of the other. That's very similar to when we were saying, two lines are equal to each other, that's where they intersect. And so we can say this equation can be solved for t and then find the time at which both containers have the same volume. So whenever they are equal, that means when we have a point of intersection. All right, and then the last part of this lesson is that exit ticket. So it looks like this. It says Lynn uses an app to graph the charge on her phone. And then it says, when did the graph start using her phone? When did she start charging her phone? And it says, while she was using her phone, at what rate was Lynn's phone battery dying? So make sure you can read that carefully and be sure to check with me. And as always, super slam that subscribe button.